Hello, my name is Dr. Dan Wedding, and this is DrWedding VB25 TCP/IP network sockets with an Arduino example and a Picaxe 28x2 example. In this demonstration, I am using components and modules that I purchased on the internet. I purchased these with my own money. I was not compensated in any way from the manufacturers or their suppliers. These are just the parts I used to make the network connections. In this video, I will use local IPv4 network addresses, ports, switches, and the TCP/IP protocol to connect a VB program to an Arduino and then a Picaxe 28x2 microcontroller. Normally, I start and finish these videos with a PowerPoint presentation. For this video, the PowerPoint was removed and made into its own video. If you are familiar with the terms used in the overview and have a basic understanding of networking, then you should be able to easily follow this video. However, if you are not familiar with these terms, or you have no networking experience, or you just feel you need to brush up on your networking skills, please watch my previous video, DrWedding VB25 Networking Basics, for beginners with little or no networking experience. There are two transport layer protocols used to send data over the internet and local networks. They are UDP/IP and TCP/IP. This video only covers connecting a VB program to a network using TCP/IP. First, the program will be connected to an Arduino Metro Mini microcontroller. Next, the program will connect to a Picaxe 28x2 microcontroller. If you are interested in UDP/IP communications, please jump to my previous video, DrWedding VB24. For both microcontroller demonstrations, the PC's IPv4 address is 192.168.0.10. This is a fixed IP address. The subnet mask is 255.255.255.0. The computer will communicate with the USR-TCP232 module. This module will convert the TCP/IP network communications into serial communications and send it to the microcontroller. Because this module is taking care of all the networking, you can add any device with a serial port to your network. On the manufacturer's website, there is a free download that will allow you to easily configure the module to your needs. You can search for the software by name as shown below. Make sure you are getting the code from the manufacturer's website. To configure your module, plug your computer and the module into a switch. Apply power to the module per the manufacturer's directions. Run the setup program. Press the Search in LAN button. The software will search the network and report all the modules it finds. The list will be displayed in the Device List in the Net window. To configure your module, select the module from the list, and then the current settings are shown in the parameters. You can change the settings. In this example, I have set the network communications to TCP/IP by selecting TCP server. The module has a fixed IP address of 192.168.0.7. The subnet mask is 255.255.255.0. The module will listen on port 57878. It will transmit to IP address 192.168.0.10 on port 51010. The serial side of the communications is set to 9600 baud, no parity, 8 data bits, and 1 stop bit. When you are finished, press the Set Selected Items via LAN button. Configure the second module the same as before. Select the module from the device list, set your parameters, and save the settings using the Set the Selected Items via LAN button. The second module is configured with the same parameters as the first module, with one difference. The IP address of the second module is 192.168.0.8. This is all the information. The best way to learn is through an example, so let's get started. I have opened up a new project, and the form for this project is on the left side of the screen. On the right side of the screen, you will see two protoboards along with the IP addresses associated with them. There are two sections on the form, a yellow section and an orange section. The yellow section will communicate with the board with the IP address of 192.168.0.7, and the orange section will communicate with the board that has the IP address of 192.168.0.8. Both sections have two buttons, one with red text and one with green text. When the button is pressed, the VB program will transmit the letter R or G to the IP address printed on the button. The board will receive the letter and toggle the red or green LED. On the board side, there are two buttons. When these buttons are pressed, the board will send B1 or B2 back to the Visual Basic program. The program will display the received data on the rich text box below the buttons. A rich text box was used instead of a text box to allow the program to change the colors of the text depending on which button was pressed. There's a text box at the bottom of the form to display any error messages. Finally, a timer has been included on the form. This allows the network traffic to be checked regularly. You should always start your program with comments, like I have done here. You might want to pause the video and read through these comments to help you understand the program. Next are the imported libraries that will allow you to communicate with the network. The project starts with global variables. The first three global variables are used to connect with the first microcontroller. The first variable is an IP address variable, and it is assigned the IP address of 192.168.0.7. The second variable is an IP endpoint variable that is made up of the previous IP address and a port number. The IP address is 192.168.0.7, and the port number is 57878. The third variable is a socket variable, and it is configured to use TCP/IP. The IP endpoint variable and the socket variable are connected to each other in form load. The next three variables follow the same format. However, these variables are used to connect to the second microcontroller at IP address 192.168.0.8. There are 2 byte arrays used to hold the values that are received and transmitted on the network. Finally, the bytes sent variable will record the number of bytes that were sent when the data was transmitted over the network, and the bytes received will record the number of bytes that were received when data was received over the network. In the form load subroutine, there's a try-catch. Inside the try, the program will attempt to connect the first socket variable to the first IP endpoint variable at IP address 192.168.0.7 on port 57878. Then the program will connect the second socket variable to the second IP endpoint at IP address 192.168.0.8 on port 57878. If there's a network error, the catch will take over and issue an error message. Next, the socket variable's blocking property is set to false. This will let the program know it should not wait for data to be received or transmitted, and this will prevent the program from locking up. The timer interval is then set to 100 milliseconds and the timer is enabled. The timer is used to monitor the network for incoming data. In the Form 1 form closing subroutine, the sockets are closed and their resources freed up. Because all 4 buttons are nearly identical, I'm going to discuss them at the same time. All 4 buttons have a try-catch. Inside the try, there are 3 lines of code. The first line is the call to the toggle color subroutine. This subroutine is not needed for communications, and it just toggles the background color of the pressed button to draw attention to it during the video demonstrations. The subroutine call can be ignored and erased if you wish. The second line converts the character string to a byte array so it can be transmitted on the network. And the third line transmits the information to the IP endpoint. The first column's IP endpoint is 192.168.0.7 on port 57878. And the second column's IP endpoint is 192.168.0.8 on port 57878. The number of bytes that were transmitted is saved in the variable bytes sent. The variable is not used in this example, but I think you should know you have access to it if you need it. Finally, if anything goes wrong with the network communications, the catch will take over and an error message will be displayed. The timer subroutine is in charge of monitoring the network for incoming data. Because TCP/IP makes individual connections, the endpoints need to be individually checked. The code to receive data from 192.168.0.7 and the code to receive data from 192.168.0.8 are nearly identical. Therefore, I'm going to discuss them at the same time. The code to receive information from the network is inside of a try-catch. Inside the try is an if statement. The if statement checks if any data was received, and if there's no data in the buffer, the if is ignored. But if data has been received, the if statement is executed. There are 3 lines inside the if. The first line receives the data and stores it in a byte array named inMessage. The number of bytes is stored in an integer called bytes received. The second line is not necessary. It just changes the color of the text based on the data that was received. It's only there to highlight the incoming data and make the video demonstration easier to understand. This subroutine call and the subroutine can be removed if you wish. The third line will print the received data on a rich text box. A rich text box was used instead of a text box because a rich text box will allow you to change the color of individual letters. If anything goes wrong when receiving the data, the catch will take over and print out an error message. Because this subroutine is here to help with the video examples, I'm not going to take a lot of time discussing it. This subroutine is not necessary for network communications. The purpose of this subroutine is to toggle the background color of the buttons or to change the text color based on the received data. I'm going to explain how this subroutine works through the use of an example. Assume button 7 red is pressed. This subroutine is called and passed to 1, and then the 1 is stored in btn. This causes the first if statement to be true, and this executes the nested if. The nested if checks the background color of the button. If it is the default color, it will change it to the highlighted color. If the button's background color is the highlighted color, it will change it back to the default color. The first 4 if statements work this way. The last 2 if statements just compare the received data to B1, and if it's a match, the text color is set to red. If it is not a match, the text color is set to blue. If you are interested in this subroutine, you may wish to pause the video and look at it more closely. Now I will run the program and demonstrate that bidirectional communication has been established over the network between the Arduino boards and the VB program. I plugged the computer and both Arduino boards into a network switch so they are on the same network. I've also applied power to the boards. There are 4 buttons on the form. When I press the buttons on the form, it sends the data to the selected microcontroller and toggles the desired LED. Each of these Arduino microcontrollers has 2 buttons attached to it. When a button is pressed, the microcontroller will transmit B1 or B2 to the VB code. The code will identify which Arduino sent the information and which button was pressed. It will display the received data on the correct rich text box. A copy of the VB code, the schematic for the Arduino boards, a parts list for the Arduino boards, and the code embedded into the Arduinos are all in a single file that is available as a free download. A link to this download is in the description below. Now I will run the program and demonstrate that bidirectional communication has been established over the network between the Picaxe 28X2 boards and the VB program. I plugged the computer and both Picaxe boards into a network switch so they are on the same network. I have also applied power to the boards. There are 4 buttons on the form. When I press the buttons on the form, it will send data to the selected microcontroller and toggle the desired LED. Each of these Picaxe microcontrollers has 2 buttons attached to it. When a button is pressed, the microcontroller will transmit B1 or B2 to the VB code. The code will identify which Picaxe sent the information and which button was pressed. It will then display the received data on the correct rich text box. A copy of the VB code, the schematic for the Picaxe boards, a parts list for the schematic, and the code embedded in the Picaxe are all in a single file that is available as a free download. A link to this download is in the description below. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.